3. Hello everyone, this is Orekoya Olusegun Physics Mathematics Fundamental. This video is on the second part of the fundamentals of vectors. But before we go into details, please do not forget to like, share, subscribe and click on the notification button so that I can have more of my video. The fundamental of vector, I've actually explained the concept of the head of a vector, the tail of a vector, the magnitude of a vector, the direction and the sense of a given vector. So now we are going to dwell on what we mean by the unit vector, the zero vector, and the direction cosine of a vector. So now let's start with number one, unit vector. Unit vector. Let's say we have this particular vector, vector AB, and this is the sense of the direction. Let's say we have a small vector. I will call it vector small a. Let's say the magnitude of this vector is 6. You see, the vector A that I have here is called unit vector, and the size, that means the size from here to here is 1. So for us to have this unit vector in 6 places, we can have something like this. This is 1, 2, 3, 4, then 5, 6. We can see that for the vector AB, we have 6 of this unit vector. So I have it as 6a. So what am I trying to say is that this is a scalar multiplication. Scalar multiplication. Scalar multiplication is simply a number without direction. So the relationship between a vector and unit vector can now be written in this format: scalar multiplication of the unit vector. And how do we get expression for unit vector? You divide the given vector by the scalar multiplication. So it's going to be vector AB divided by S is equal to the unit vector. Now, for instance, example, we may be asked to determine find the unit vector in the direction of vector AB given as 3i plus 4j. Now, we know very well that the unit vector A, like I said, is the vector AB divided by the scalar multiplication. And the scalar multiplication that we have here is the magnitude of vector AB. So the magnitude of vector AB I have here is 6. Now, I want us to note something. The magnitude of vector AB, we can write it as this. And this magnitude, if vector AB is given as xi plus yj, the magnitude, that the size of that vector AB, is given using Pythagoras theorem, is given as square root of the coefficient of unit vector I and the coefficient of a unit vector j. Those are the ones we are going to have. You square the coefficient of the respective unit vector. That's the magnitude of vector A. Please take note of that, magnitude of vector A. So in this particular question we are having now, this scalar multiplication of unit vector A is the magnitude of vector A, so which I can write it as vector AB divided by magnitude of vector AB. And then the vector AB is 3i plus 4j. 3i plus 4j. 3i plus 4j. Then divided by magnitude of vector AB. When we use, look at this, when we use this formula, the magnitude of vector AB given this coefficient of unit vector is x squared plus y squared. So here now our x and our y are 3 and 4. So I have square root of 3 squared plus 4 squared. So the unit vector A now can now be written as 3i plus 4j divided by 3 square is 9. 4 square is 16. 16 plus 9, that's 25. Square root of 25 will give us 5. So the unit vector A now is going to be 3i divided by 5 plus 4j divided by 5, which can also be written as 1 over 5 because this 5 is common. Brackets 3i plus 4j. Now, a first thing I want us to realize is that direction cosine can be directly obtained. Direction cosine of vector AB can be obtained from the expression of this unit vector. It's just the coefficients of the I and the j of the expression we have for the unit vector. So direction cosines of our vector AB, we can write them as cos theta. This is the cosine, is given as 3 over 5, and the second one we can write it as cos beta is equal to 4 all over 5. So this is how to find the value of the unit vector if we are given a vector. The same idea can be extended to 3D. Now this idea of this direction cosine of vector AB, let me just give you an idea. So I'm going to clean up what I have here now and then introduce the idea of direction cosine. What do I mean by direction cosine? Direction cosine. Now, let's say the vector AB that I discussed earlier it lies on the Cartesian coordinates system y, x, and then this is the A, the tail, and this is the B, the edge of the vector. So the direction of AB with respect to the x-axis, call it theta, and direction of vector AB with respect to the y-axis, call it beta. The cosine of theta and beta are called the direction cosine. Now let's say the location of point B along the x-axis is x and along the y-axis is y. So we have point x, y. So I'm going to take the cosine of this theta and this theta with respect to this right angle triangle and with respect to this other right angle triangle. So for the theta, cos theta is equal to adjacent. Adjacent is from A to this place, that is x, all over hypotenuse. And the hypotenuse here is a magnitude of vector AB. So I can have it as x all over, adjacent over hypotenuse, that is x all over this. And then the magnitude of this vector AB using Pythagoras theorem, I have x divided by, so having this magnitude of vector AB using Pythagoras theorem is a square root of this x square plus this y square. So this is the direction cosine for the angle theta which vector AB made with the x-axis. Now for the second direction cosine of vector AB is cos beta. Cos beta for this one now is this adjacent, that is y divided by the hypotenuse, y divided by the hypotenuse, and the hypotenuse is the magnitude of vector AB, which is a y divided by square root of x squared plus y squared. So in a nutshell, if I want to write vector AB out, it's as if I'm moving from point A to the terminal point B. I will write it like this, in this direction. It's the same thing I'm moving from here to here, which is x, and the direction I'm moving along the x-axis is I, so I will write it as xi, and moving to this place. So if I'm moving from A to B, I will move in this I direction in 3 units and in x units, and move along this y direction in y units. So I'll write it as plus yj. So you can see now that when you want to write direction cosine now, it's just taking x divided by the magnitude of this vector and also taking y divided by the magnitude of the same vector. So this is the idea of a direction cosine of a vector. Now I want to discuss about the zero vector. Zero vector. Zero vector, I will use this figure. It's a vector that has zero magnitude. A zero vector has zero magnitude but but no define sense and direction, but no define sense and direction. So that's the zero vector. Now let me give an idea of this zero vector. Let's say I have vector AB. Okay, the zero vector will be explained in my next video. Thank you for listening. I will, because of some technical issue, I'm going to stop it here and continue in my next video. Thank you. Have a